In section 9.1, we worked on confidence intervals for population proportion. But in section 9.2, we're going to work on confidence intervals for population mean instead, for mu. So let me give you an example. Water scarcity is a serious problem for the countries in the Middle East, including Israel. The governments of countries in the Middle East are regularly monitoring water usage by their people. A recent Israeli government study sampled 49 random Israelis. From that, they were able to predict that the average Israeli uses 72 cubic meters of water daily, plus or minus 10.816 cubic meters of water, with 99% confidence. A couple of things. You might notice that this is a smaller sample than what we're used to seeing for proportions. And you'll learn later on in this chapter that that's probably okay. We'll figure that out a little bit later. So let's start with describing the population of this study. So this is the Israeli government. They're polling random Israelis, right? And they want to predict the average Israeli uses how much water per day. So the population would be all Israelis, right? People that live in Israel. All right, that's simple enough. Now the sample, we're going to describe it. So the sample was the 49 random Israelis right there. So let me highlight that. All right, so that was our sample. So I'll say that. Describe the sample. And the answer is it was the random Israelis chosen. Why is it important that the sample is random? Well, because otherwise you could be biased, right? And we don't want a biased sample. So it's important to keep randomness in there because you don't want your study to be biased. Oh, I didn't even notice this. They also want to know the size. So it was n equals 49, right? That was the size of our sample. And again, it's a little small, but that could actually very well be okay. We don't know yet until we see a couple sections from now when we deal with sample size. All right, so the sample would be the random Israelis chosen. There were 49 of them. And then why is it random? Why is that important? That's to ensure that the study is not biased. We do not want biased studies. And again, notice that we do not need as large a sample for doing means, for estimating means, as we did for proportions. And we'll see more of that later on. Right, then it wants us to create a graphical display that shows the predicted interval for the daily water consumption of Israelis. So you'll notice right here it says uses 72 cubic meters of water daily. Right, so there's your center. That's your point estimate. So you think it's going to be 72, and then it says plus or minus 8.16. That's your margin of error, right? So what we're going to do is we're going to take a calculator, and we do 72 minus 10.816. That gets us 61.814, or 184, excuse me. Let me make this bigger so you can see it. And then 72 plus 10.816, which is 82.816. And then we're going to build that as an interval. And I already drew it by hand. So over here I have the 61.184, and that was 72 take away 10.816. And over here I have 82.816. Smack dab in the middle is my point estimate, just like in section 9.1. For means, just like for proportions, your point estimate's in the center, which in our case was 72 because that's what they thought it would be. They thought it would be 72 cubic meters of water. Then you add on, subtract away your margin of error, which was the 10.816. That error is that distance between the edges and that center. So the confidence interval itself is the two edge numbers, the 61.184 and the 82.816. So the next question asks us, what is the point estimate for this confidence interval? Okay, well, the point estimate is the center of the interval, so that's what we're going to see. So it's in the point estimate is in the exact center / middle of the interval, right? I don't like that font at all. There we go. Okay. Now, what was it? Well, its value was x bar, which is equal to 72. And it was cubic feet or whatever, cubic feet of water, but it doesn't really matter for our purposes. So 72. What was it? Cubic meters, that was it. So 72 meters cubed. So technically, all of this has a meters cubed unit attached to it, even though we don't actually put them in there. So you could say 61.84 meters cubed, and then 81.21 or 82.816 meters cubed, right? That would be the unit for this one. Now, we didn't really have units for proportions because proportions are always percentages, so they don't really have a unit. But for here, we would have whatever unit our data was, which in this case was meters cubed. All right, so then, exact center of the interval. All right, what was the margin of error? Well, that's the distance from the center out to the edges, which was given to us as 10.816. And you could find it by taking half the width if you wanted, right? The width of the interval is from the high end to the low end. So let me type that up. Okay, so here it is. It's 10.816 meters cubed. It was given to us in the problem. Where does it show up in the graph above? Well, the error is half the width. Let me paste it in from before. The error is equal to half the width right here. Or if you like, double your error is equal to your width. So we had 10 or 2 times 0.816 or 10.816 would make my width. Okay, so let me type it up again. So remember that half the width is equal to your error. So if you take half your width, now your width is found by taking your high number, which is 82.816, minus your low number, which was 61.184. So when you do that with a calculator, and you can see I already did it, but I'll do it again. 82.816 minus 62. I can't remember the number. 61.184. Okay, 82.816 minus 61.81. Oh, I just did it wrong again. 61.184. There it is. 184. I knew I was messing up. Then you get 21.632. Then you divide it by 2. And you get 10.816. And that would be your error right here. So that's another way to see it. So I know it was given to you, but just a little reminder. So where do we see it in the graph? The error is the distance from the center to the edge, which is half the width, right? It's half the width of your interval. And then I'm just going to put this part right here. Right, so we learned that back in section 9.1, and it's still holding true in section 9.2, that your error is half your width. So this is another way to find the exact same number, which is 10.816.